Assalamualaikum warahmatullahi wabarakatuh. I am Iskandar Zulkarnain bin Basri, 1813187, and my group mate is Afif Fanshuri bin Shamsolnizam. Our team is supervised by Assistant Prof. Dr. Noor Azura Zakaria, and we are from Development Group 809D. I'm going to start the presentation by doing some introduction on our heart monitoring application. Our team are going to develop an application that can be used for analyzing user heart rate by using only smartwatch and smartphones. In the era of technology nowadays, the usage of heart rate detector were used widely. Not only were used for hobby such as sports, but it also can be used in medical field by alerting heart patient contacts whenever abnormal cases were detected. Even though our application is low cost and straightforward, the end result will be accurate and high performance as we include machine learning in the implementation of the heart disease. The main target for this application is for the public, especially for the elderly and for patients with heart disease, so that they did not need to go to the health facilities and use expensive hospital equipment. Now, we proceed to take a look at the problem statement for this project. From our findings, there are lack of low-cost, convenient device that can connect heart disease patients with healthcare professionals. The ones that are available in the market are either too expensive or need lengthier response time. Therefore, in this project, we are going to develop a machine learning algorithm in order to determine the patient's abnormal heart rate. Next, we want to create a functional heart monitoring system that can assist those with the risk of heart disease. And lastly, we are going to implement Android device and technology to create a wearable heart monitoring system. Now I proceed with literature review. For this part, we have two sections. The first one is we review algorithm, and the next one is we review previous system. In order to develop this project, we plan to use machine learning algorithm to find the patient abnormal heart rate. However, there are many types of machine learning algorithm available, such as support vector machine, decision tree, linear regression, and many more. Therefore, in order to choose the best algorithm that is suitable for our project, we have conducted several research by looking into several previous papers. As we can see in the table, our team have summarized the most accurate algorithm that can be used for our dataset. They are SVM, logistic regression, and KNN. From all the algorithm, we test them ourselves to find out which one of it is the best algorithm to be used for our project. Besides that, we also studied 3 previous systems that is quite similar with our project. Here we can see there are some pros and cons for each of the system. For example, the first system has emergency alert system and use high-tech technology, but it is expensive and does not include algorithm in their system. On the other hand, the personal heart monitoring system, even though the device used is high cost, they lack in terms of convenience and the technology used. Lastly, the Android-based monitoring system is pricey, but excel in terms of machine learning algorithm that they use in their system. From the observation of this previous system, our team obtained useful insight on how to improve and innovate new system that is low cost, convenience, but high performance in terms of accuracy and alarming feature.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afif Fanshuri bin Shamsolnizam, 1818765, and I will present to you about the methodology that we have applied in our application development. For our application development, we have applied an iterative model which consists of planning and analysis. And in each iteration, we will have designing phase, implementation phase, testing phase, and reviewing phase. And after the system is ready to finalize, we will deploy the application. To start the designing phase, we have created a system overview which is described in this use case. The use case consists of 4 actors, which are the user, administrator, sensor, and the smartwatch. The user acts as the main actor here because most of the functionalities serves the user. The functionalities are described as use cases here, such as register, login, checking the Bluetooth settings, pairing with a smartwatch, and monitoring the heart rate. These are basically the main functionalities of our system. We also have the administrator, which functions as to maintain the system, managing the database, and also they can log in into the system. Lastly, we also have sensor and smartwatch, which functions to retrieve the heart rate and sending the heart rate. In the designing phase, we also have created a user interface for our application, which consists of two user interfaces, which are the interfaces for the mobile application and also the smartwatch application. And now I will demonstrate to you how the user interface in the application looks like. Firstly, in the main page, we have the logo of the application and also where user can log in and sign up for the application. If the user logs in the application, they will be directed to the main home page, which they can also be logged out. If they don't have an account, they can also sign up to create an account, which we will firstly ask for their personal details such as name, password, phone number, and also emergency contact, which will be used later if there is an abnormality detected. And next, we also ask for their medical conditions, which will be used later in the algorithm development. And then when they click sign up, they will instantly create an account and they can use the features of our application. To use the application, the users must first connect to a smartwatch. This is because they will have to retrieve the heart rate and send it to the mobile application. To do this, the users must first go to the Bluetooth settings, where all the devices that are discovered will be displayed. If they see or they have paired the smartwatch to the application, they can click on the name of the smartwatch, and it will automatically connect with the smartphone. And then after that, users can start to monitor the heart rate by clicking the Start Heart Monitor. I almost forgot. In the homepage, details such as recent heart rate, recent maximum heart rate, and users' health status will be displayed. In the heart monitoring page, the users can start to monitor the heart rate by clicking Start. In this demonstration, we will demonstrate how the application will respond to an abnormal heart rate. As you can see, when there is an abnormal heart rate, the application will pop up a notification asking the user to press yes if the user needs medical assistance. And in case of the user does not respond to this notification, the application will automatically send alert to their emergency contact. And if the users press deny, it means that user is okay and the application will continue to retrieve their heart rate. And to stop the heart rate retrieval, the users can click on stop. For the user interface of the smartwatch, it is similar to the mobile application, which consists of the home page, the Bluetooth settings page, and the heart retrieval page. In the home page, the users can choose to check the Bluetooth settings or retrieve the heart rate. If the users are already connected to the smartphone, then they can proceed to retrieve the heart rate. If not, they can go to the Bluetooth settings and connect to the desired smartphone. After they have connected to the smartphone, they can start to retrieve the heart rate. They can start retrieve the heart rate by clicking the start button. And this indicates that the retrieval of the heart rate has already begun. If they wish to stop the retrieving of the heart rate, they can click stop button. For the data source of our application, which is going to be used in the algorithm development, we have decided to import an open source dataset called Heart Disease UCI from Kaggle. Kaggle is an open source dataset repository. This dataset is very reliable as it is created by several health institutions. This dataset consists of 13 attributes which describes symptoms of heart disease. After the designing phase, we will continue with the implementation phase, which is the development of our application. For this, we use several tools such as TensorFlow for machine learning purposes, Python programming, which is used by TensorFlow, RStudios for data cleaning and preprocessing, and Android Studios for our mobile application development. To start the implementation phase, we first pre-process the data that we have obtained from the data source earlier. The data pre-processing consists of data cleaning and data transformation. This is because we want the data to be fit so that we can insert it into the machine learning algorithm. Firstly, we clean the data such as removing missing values or removing duplicate data. We also remove outliers so that there won't be any noise or biased data. And then after that, we transform the data into suitable formats, such as converting data types into suitable data types, and also renaming variables for ease of understanding. To continue with the implementation phase, we have searched for the best algorithms to apply it in our application. To do this, we have reviewed past works that also works on the same dataset as we did. And from the analysis that we have done, we found out that SVM has the highest accuracy among all other algorithms with 91%. This is followed by KNN, which is K-nearest neighbor, with 88%, ANN, artificial neural network, 87%, and also logistic regression, 86%. We have decided to choose ENN as the algorithm to implement in our application. This is because our application is built on an Android environment. That is why, because we built in Android Studio. Android Studio has a built-in platform for TensorFlow. This is for the users who wants to implement machine learning algorithms in their application. TensorFlow is an open source library that specializes in deep learning and neural networks. So hence, that is why we choose ANN to implement it in our application to ease our task in converting the algorithms in a comprehensible format suitable for Android Studio. Not to mention, ANN also achieves one of the highest accuracy, which is 87%, beating logistic regression at 86%. Although SVM is higher, we choose ANN because it will help to ease our task in deploying machine learning algorithm in the application. For the database development, we have decided to use SQLite, which is an internal database in Android Studio. Android Studio provides a built-in database for users to use. This database serves a good use, especially for those who aim to build a small-scale application or system. The database, called SQLite, uses a hybrid of Java and SQL programming for its syntax. For our system, we will be using this database to store the information of our users as well as their medical conditions. After the implementation phase of our system, we proceed to the testing phase. For this testing phase of our system, we have decided to test using a prototype. A working prototype of the system will be made using the Android Studio IDE. The prototype will be developed based on the preliminary design analysis of the system, which we have did earlier. This the focus of the prototype will be on the basic functionalities of the system. The efficiency of the algorithm will also be tested. The training set will be fed into the algorithm to train the model, and the testing set will be used later in the prototype. The testing set will serve as a new user and will be further analyzed whether the system can classify it as a risk of heart disease or not. And lastly, after the testing phase, we have the review phase, which is a phase where we look back at the iteration and improve the deficiencies and errors that we have encountered along the way. During the first iteration, which we are at now, we completed all of the important planning and analysis of the design for this application. All the important analysis such as data sources, what the user interface looks like, the databases implementation are all discussed in the first iteration. And then we also discuss the algorithm development of the system and chose the best algorithm to apply it in the application. And then from this iteration, we will review, and in the next iterations, we will improve or add any other functionalities or add any other improvements that can be made to our application.